Hello, good evening everyone. In the last class is discussion about capacitance of a capacitor. Capacitance of a capacitor. The capacitor means it is a electronic device. The capacitor is an electronic device. It is a storage of charges. The storage of charges. That is, and it is a representation of capacitor is it is consist of two conductors. One conductor is consist of positive charges, another conductor is consist of negative charges. Q plus Q minus Q be the charges. The potential difference between the two conductors is that is the V. That means the capacitance of a capacitor it is represented by C is the symbol. It is symbolically it is represented by two conductors are parallel to each other. Each conductor of a charge is Q and Q. The potential difference between these two conductors is that is taken as V. That means, what is the definition of capacitance of a capacitor? The capacitance of a capacitor is defined as the charge of each capacitor to potential difference between each conductor. That is given by C is equal to Q by V. That is the formula. C is equal to Q by V. That means the capacitance of a capacitor is defined as the charge acting for unit potential difference. The charge acting for unit potential difference, that is called capacitance of a capacitor. Or it is also defined as the charge of each conductor to potential difference between these two conductors, that is called capacitance of a capacitor. It is symbolically it is represented by two conductors are parallel to each other. The two conductors are parallel to each other. That is the symbol of capacitance of a capacitor. Then it is capacitor. It is a system of two conducting plates separated by a insulator, and it is what is the SI unit of capacitance of a capacitor? The SI unit of capacitance, the standard SI unit of a capacitance of the capacitor is that is a farad. Farad. That is the symbol is F. Small f. Small f is that is the SI unit of the capacitor is farad. It is represented by the symbol is F. That means the farad, the 1 farad or farad is defined as what is the meaning of farad? The farad is defined as the capacitance of a capacitor is said to be 1 farad. The charge on the capacitor is the charge of the capacitor is 1 coulomb, and the potential difference between the plates is the potential difference is 1 volts. The potential difference is 1 volts. That is called 1 farad. The 1 farad means the 1 farad is defined as the capacitance of a capacitor is said to be 1 farad means when a charge on each conductor is 1 coulomb, each capacitor is 1 coulomb, and the potential difference is 1 volts. That is called 1 farad. That is the concept of the capacitance of a capacitor. What is the definition? What is the symbol? What is the SI unit of capacitor? And parallel plate capacitors. Parallel plate capacitor. Parallel plate capacitor. The parallel plate capacitors means the parallel plate capacitor consists of two metal conductors, two metal plates. It is parallel to each other. Next concept is parallel plate capacitor. That is the one is the metal plate. First one is that is the X is the metal plate. The one more parallel plate is that is Y. X, Y is the two parallel plates. Two metal plates. It is the direction of these two parallel plates it is parallel to each other. Parallel to each other. And it is the X metal plate is it is consist of positive charges, and the Y conductor is consist of negative charges. The distance between these two conductors is a small d. Small d is the difference between the two conductors. That is, the E is a electric field line. E is a electric field line, and the each conductor of a area is A and area is A. The capital A is the area of the each conductor. And what is the sigma? Sigma is a surface area, a surface density charge. The surface density charge. What is the density? Density means the mass by volume is called density. The surface charge, it is represented by symbol is sigma. The charge, that is a charge acting for unit area, is called surface charge density. The surface charge density means the charge acting for unit surface area is called surface charge density. That is the explanation part of a parallel plate capacitor. What is the meaning of parallel plate capacitor? That means the parallel plate capacitor means it is consists of two metal plates are parallel to each other. That is called parallel plate capacitor. How to derive the expression for the parallel plate, the capacitance of A, the capacitance, C is the capacitance. Derive the expression or find the capacitance of parallel plate capacitor without dielectric media. Without dielectric medium. The dielectric means what? It is an insulator. First to draw the two metal plates, X and Y is the two metal plates. In the presence of electric field line, the A is the area of each conductor. That is, the distance between the two metal plates is the small d. And the sigma is a surface charge density. Consider the two metal plate capacitors. Consider the parallel plate. The capacitance of a capacitor C. C is a capacitance of a capacitor as shown in the figure. D is the distance between the two metal plates, and A is the area of the each plate. E is called uniform electric field between the two plates. That is V. What is the potential difference of each capacitor? The potential difference between the each plate. And sigma is called surface charge density. By using a basic definition of capacitance. The definition of capacitance. What is the capacitance? The capacitance means the charge acting for potential difference. That is C is equal to, that is Q by V. That is called equation number 1. By using a basic definition of the capacitance of a capacitor is C is equal to Q by V. That is called equation number 1. The electric field is a electric field line. The electric field between the plate is given by, the electric field means what? The force acting for unit positive charge. The force acting for unit positive charge is called electric field. My question is the electric field between these two plates. The electric field between these two parallel plates is given by, that is the electric field must be is equal to what is the potential difference of each plate and the distance between these two plates, that is D. E is equal to V by D, that is called equation number 2. The electric field between these two plates is E is equal to V by D. And the electric field of each conductor is, that is sigma by 2 epsilon naught, sigma by 2 epsilon naught and sigma by 2 epsilon naught. The electric field due to the each metal plate is given by sigma by 2 epsilon naught, sigma by 2 epsilon naught. What is the total electric field? Therefore, the total electric field means the two thin charge plates, that is a E is equal to sigma by 2 epsilon naught, sigma by 2 epsilon naught. The electric field due to the first conductor, the electric field due to the second conductor, that is a 2 times of a 2 sigma by 2 epsilon naught. 2 get cancelled, that is E is equal to sigma by epsilon naught. That is called equation number 3. The equation number 2 is the electric field. The equation number 3 is also electric field. Electric field. Comparing equation 2 and 3. Comparing equations 2 and 3. The equation 2 and 3 comparing the electric field both sides get cancelled. Write the RHS part. That is V by D is equal to, equation number 3 is sigma by epsilon naught. Find the value of potential difference. Therefore, the potential difference V is equal to, that is sigma D by epsilon naught. That is the potential difference. The potential difference V is equal to sigma D by epsilon naught. That is called equation number 4. The potential difference V is substitute equation number 1. Equation number 1. What is the equation number 1? From the equation number 1 is given by, that means the equation number 4 in 1 we get. That is, the equation number 1 can be written as, that is, capacitance of a capacitor C is equal to the potential Q by the charge is Q. The potential difference is V is what? Sigma D into epsilon naught. Sigma Q by sigma D into epsilon naught. That is the N equation. But the Q is a net charge. Q is a net charge. By using presence of surface charge density, by using a basic definition of surface charge density, that is sigma is equal to charge per acting charge by area. The charge acting for unit area. Find the value of Q. Q is equal to what? Sigma A. This value is substituted in the above previous equation. Therefore, C is equal to the total charge is sigma A by sigma D into epsilon naught. Sigma get cancelled. Sigma get cancelled. Therefore, finally, the capacitance of parallel plate capacitors without dielectric media, that is C is equal to A epsilon naught by D. This is the expression for the capacitance of a parallel plate capacitor without dielectric media, where epsilon naught is the permeability of a free space. Permittivity of a, not permeability, permittivity of the free space. Capital A is the area of the each conductor. Small d is the distance between the two conductors. C is a capacitance of a capacitor. C is called capacitance of a capacitor. This is the concept of the parallel plate capacitor. Once again, first to draw the two metal plates. It is parallel to each other. It is a representation symbol that is also called capacitor symbol. The X and Y is the two metal plates. It is parallel to each other. The potential difference of the each conductor is V. The area of each conductor is A, and sigma is the surface charge density. Small d is the distance between the two metal plates. The small d is a distance between the two metal plates. That is the explanation part of a parallel plate capacitor. First, by using a basic definition of capacitance of a capacitor, the C is equal to Q by V. That is called equation number 1. And the electric field between the two metal plates, that is called, what's the potential, what's the distance between the two plates, that is called electric field. The electric field between the two parallel metal plates is, that is A is equal to V by D. That is called equation number 2. The each conductor of a electric field is, that is sigma by 2 epsilon naught, sigma by 2 epsilon naught. That is the total electric field. The total electric field is equal to sigma by epsilon naught. Sigma by epsilon naught. That is called equation number 3. That is the equation 2 and 3 are the electric field lines, electric fields. Electric field, both sides get cancelled. Comparing equation 2 and 3, that is the RHS parts, V by D is equal to sigma by epsilon naught. Cross multiply and simplify the potential difference. The potential difference is equal to, that is sigma D by epsilon naught. Sigma D by epsilon naught. That is the equation number 4. The equation number 4 is, that is the potential difference The equation number 4 is substitute equation number 1. That is equation number 1 is called what? That is the capacitance definition. That is C is equal to Q by V. Q by, what's the potential difference? Sigma D. Sigma D is a reciprocal is changes to product. That is Q epsilon naught by sigma D. But the sigma is called surface charge density. What is the definition of this surface charge density? Charge acting for unit area. Charge acting for unit area. That is, find the total charge. The charge is equal to sigma E. This value is substituted in this equation. The capacitance of a capacitor is equal to, that is, the charge is sigma E into epsilon naught by sigma D. Sigma get cancelled. Finally, we will get C is equal to A epsilon naught by D, where A is equal area of the each conductor metal plate, epsilon naught is the permittivity of the free space, D is the distance between the two metal plates, C is a capacitance of a parallel plate capacitor. This equation, the final equation is called, that is the capacitance of a parallel plate capacitor without dielectric media. Then similarly, what is the expression for the capacitance of a parallel plate capacitor with dielectric media? Dielectric medium. That is, epsilon naught is the permittivity of the free space. What is the meaning of dielectric media? Dielectric constant and relative permittivity both are same. That is, epsilon r is called relative permittivity or dielectric media. That is, epsilon r is equal to epsilon by epsilon naught, or epsilon is equal to epsilon r into epsilon naught. The epsilon is the permittivity of a material media, that is also called dielectric media. Epsilon r is called relative permittivity, dielectric constant. Epsilon naught is the permittivity of the free space. My question is, mention the expression for the capacitance of a parallel plate capacitor in a dielectric media with dielectric media. As it is same, that is the capacitance of a parallel plate capacitor. Similarly, that is C is equal to the dielectric media, or the dielectric media means that is epsilon. That is, what is the value of epsilon? That is epsilon or epsilon naught, area of each conductor, distance between the two metal plates. This is the expression for the capacitance of a parallel plate capacitor with dielectric media. Where epsilon naught is the relative permittivity of the material media, or relative permeability, relative constant, dielectric constant. And what is the epsilon naught? That is, epsilon naught is the permittivity of the free space. A is called area of each conductor, small d is called distance between the two plates, and C is a capacitance of parallel plate capacitor. Then what is the factors of this parallel plate capacitors? What is the factors on which the capacitance of parallel plate capacitor depends? First factor is, it is a area. What is the area? That is, the area is directly proportional to the area of the each plate. That is the first factor. What is the first factor? It is the capacitance of a capacitor. It is directly proportional to area of each plate. And second factor, it is D. D is called what? It is inversely proportional to distance. That means the capacitance of a capacitor is inversely proportional to what? That is a distance between the plates. And the third factor is, it is directly proportional to the dielectric constant. That is a epsilon r. Epsilon r is a dielectric constant or relative permittivity. That is, the capacitance of capacitor is directly proportional to the epsilon R. That means the capacitance of a capacitor, it is directly proportional to the dielectric constant of the medium between the plates. That is the factors of the capacitance of two parallel metal plates. That is the capacitance of parallel metal plate capacitor. It is directly proportional to area and inversely proportional to distance and directly proportional to dielectric constant. Dielectric constant. That is the factors is very important. 2 marks question important, and the derivations is 3 marks question is 3 mark important. And one more question is my question: how can increase the capacitance of a parallel plate capacitor? How can you increase the capacitance of a parallel plate capacitor? How can increase the capacitance of parallel plate capacitor? It means the capacitance of a parallel plate capacitor can be increases by increasing the what? Increasing the area of the plate and decreasing the distance between the two metal plates, decreasing the distance, and the higher the epsilon r, the epsilon r means the media of the higher the dielectric constant between the plates. That means increasing the dielectric constant between the two metal plates. This is the concept of parallel plate capacitor. Capacitance of parallel plate capacitor. What's the meaning? First, what's the meaning of parallel plate capacitor? What is the expression for the capacitance of parallel plate capacitor without dielectric media? That is C is equal to A epsilon naught by D. And what is the expression for the capacitance of a? There is no derivation, directly write equation. That is, what is the expression for the capacitance of a parallel plate capacitor with dielectric media? That means epsilon or epsilon naught by ED. And what is the factors of the capacitance of a parallel plate capacitor is depends. And how can increase the capacitance of parallel plate capacitor? Which one is the increasing? Which one is the decreasing? This is the concept of the capacitance of a capacitor. Capacitance of a parallel plate capacitor. Then next concept is, what is the expression for energy stored in the capacitor? What is the expression for energy stored in the capacitor? Energy stored in the capacitor. How to draw this one? How to explanation and how to draw the circuit diagram, and the final expression for energy means that the symbol of energy is that is U. The symbol of the energy is represented by U. First, draw the capacitance symbol, that is the capacitance. It is consist of two parallel conductors. It is consist of positive charge and negative charges. The capacitor is connected to the battery. Battery means it is a potential difference. The positive of the battery is connected to the one end of the conductor. The negative of the battery is connected to the other end of the conductor. Okay, na? That is also called potential difference. When a battery is connected across the uncharged capacitor, the charge transfers from one plate to another plate. The Q is called what? Charges. The plus Q minus Q is the charges. V is the potential difference between the two plates or battery. First of all, by using a basic definition of what capacitance of a capacitor. The capacitance of a capacitor means it is a V is equal to the capacitance of capacitor C is equal to charge acting for unit potential difference. What is the potential difference of this circuit? Or V is equal to Q by C. That is called equation number 1. The potential difference of this capacitor is V is equal to Q by C. That is called equation number 1. let the dq be the charge, extra charge, dq be the extra charge, the charge transferred in the capacitance, the potential difference is V. That means the small work done, the dq is a charge is transferring A in this circuit, the dw is a small work done transferring a charge dq. The work done, what is the work done? The basic definition of work done is force into distance, force into distance. By using the small work done dw transferring the charge dq in this circuit. What is the equation? That is dw is equal to, that is the charge of this circuit is dq, the potential difference is V into dq. That is the definition of work done. The work done is transferring a charge dq is given by dw is equal to V dq. dw is equal to V dq. That is called equation number 2. The equation number 1 is potential difference. The equation 1 is substitute. Equation number 2 we get. The equation number 1 is substitute. Equation number 2 we get. Therefore, the small work done dw is equal to, what is the potential difference? That is V is called Q by C with respect to dq. With respect to dq. The total work done after the small work done, then next step is find the total work done. The total work done. The total work done transferring a charge dq from the distance is 0 to capital Q. It is taken as 0 to capital Q. The total work done is W is transferring a charge is dq from the distance is 0 to Q is given by the total work done W is equal to from the distance is 0 to Q, that is dW. dW, or the total work done W is equal to the integral of 0 to Q. Substitute the dW value. What is the dW value? The dW, the small work done transferring a charge is dq is given by, that is Q by C dq. Q by C dq. Then the 1 by C is a take outside, integral of 0 to Q, then Q into dq. And a standard formula of integral of x dq is called, that is x square by 2. The standard integral formula x integral of x dx is x square by 2. And that is also one more formula is x power nx dx. The integral of x power n, n is the integer, x is the functions with respect to dx, that is x power n plus 1 divided by n plus 1. As it is same, the q power is 1 is there, that is q power 1 plus 1 divided by 1 plus 1, that is q square by 2. That is the integral of q with respect to dq, that is the total work done W is equal to 1 by C, that is q square by 2, that is upper limit is q, lower limit is 0. That is the 2 is the integer, that is take outside 1 by 2c, bracket open, the upper limit substitute, q, small q is replaced by upper limit, the q is replaced by lower limit, that is q square, upper limit is q square minus lower limit is 0. Therefore the work done is equal to, that is q square by 2c. Q square by 2c, or the work done is stored in the capacitors. The work done is stored in the capacitor. In the electric potential is U. That means W, the total work done, W is equal to U. Finally, U is equal to Q square by 2C. Now, where U is called electric, that is U is called potential, that is the energy. That is the energy. U is called energy. Q is a total charge. C is a capacitance of a capacitor. The Q is called capacitance of a capacitor. This is the expression for energy stored in the capacitor. Expression for energy stored in the capacitor. This is the expression, energy expression. First law of the one capacitance. It is capacitance is connected to the potential difference by using a basic definition of capacitance. What is the potential difference of this capacitor? That is called equation number 1. The small work done is dw, transferring a charge is dq. That is the equation number 2. The equation number 2 is substitute. The equation number 2 is substitute. Equation 1 is substitute. Equation number 2. And then right next step is what is the total work done transferring a charge dq from the distance is 0 to q. That is the total work done means by using the integration symbol. Finally we will get substitute integrate the integral of q dq is that is q square by 2. Substitute upper limit and lower limit. Upper limit is q square minus lower limit is 0. Finally the work done stored in the capacitance in a potential energy. The work done stored in the capacitor, but means what energy is, that is W is equal to U, that is U is equal to Q square by 2C. Q square U is equal to Q square by 2C. That is C is a capacitance of a capacitor, Q is a net charge, and E is a energy. This is the expression for energy stored in the capacitor. This is also important 3 marks question. Thank you. Continue to the next class.